A green wall is a wall partially or completely covered with greenery that includes a growing medium, such as soil. Most green walls also feature an integrated water delivery system. Green walls are also known as living walls or vertical gardens. It is useful to distinguish green walls from green facades. Green walls have growing media supported on the face of the wall, while green facades have soil only at the base of the wall and support climbing plants on the face of the wall to create the green, or vegetated, facade. Green walls may be indoors or outside, freestanding or attached to an existing wall, and come in a great variety of sizes. As of 2015, the largest green wall covers 2,700 square meters and is located at the Los Cabos International Convention Center, a building designed by Mexican architect Fernando Romero for the 2012 G20 Los Cabos Summit. Green walls have seen a recent surge in popularity. Of the 61 large-scale outdoor green walls listed in an online database provided by greenroof.com, 80% were constructed in or after 2009 and 93% dated from no later than 2007. Many iconic green walls have been constructed by institutions and in public places such as airports and are now becoming common, to improve the aesthetics. For example, Edmonton International Airport, Singapore Changi Airport and Chhatrapati Shivaji International Airport. While Patrick Blank is sometimes credited as having developed the concept in the late 1980s, the actual inventor is Stanley Hart-White, a professor of landscape architecture who patented a green wall system in 1938. Types. Green walls are often constructed of modular panels that hold a growing medium and can be categorized according to the type of growth media used, loose media, matte media, and structural media. Loose media equals, loose medium walls tend to be soil on a shelf, or soil in a bag type systems. Loose medium systems have their soil packed into a shelf or bag and are then installed onto the wall. These systems require their media to be replaced at least once a year on exteriors and approximately every 2 years on interiors. Loose soil systems are not well suited for areas with any seismic activity. Most importantly, because these systems can easily have their medium blown away by wind-driven rain or heavy winds, these should not be used in applications over 8 feet high. There are some systems in Asia that have solved the loose media erosion problem by use of shielding systems to hold the media within the green wall system even when soil liquefaction occurs under seismic load. In these systems, the plants can still uproot themselves in the liquefied soil under seismic load, and therefore it is required that the plants be secured to the system to prevent them from falling from the wall. Loose soil systems without physical media erosion systems are best suited for the home gardener where occasional replanting is desired from season to season or year to year. Loose soil systems with physical media erosion systems are well suited for all green wall applications. Matte media matte type systems tend to be either coir fiber or felt mats. Matte media are quite thin, even in multiple layers, and as such cannot support vibrant root systems of mature plants for more than 3 to 5 years before the roots overtake the mat and water is not able to adequately wick through the mats. The method of reparation of these systems is to replace large sections of the system at a time by cutting the mat out of the wall and replacing it with new mat. This process compromises the root structures of the neighboring plants on the wall and often kills many surrounding plants in the reparation process. These systems are best used on the interior of a building and are a good choice in areas with low seismic activity and small plants that will not grow to a weight that could rip the mat apart under their own weight over time. It is important to note that mat systems are particularly water inefficient and often require constant irrigation due to the thin nature of the medium and its inability to hold water and provide a buffer for the plant roots. This inefficiency often requires that these systems have a water recirculation system put into place at an additional cost. Matte media are better suited for small installations no more than 8 feet in height where repairs are easily completed. Sheet media semi-open cell polyurethane sheet media utilizing an egg crate pattern has successfully been used in recent years for both outdoor roof gardens and vertical walls. The water-holding capacity of these engineered polyurethanes vastly exceeds that of coir and felt-based systems. Polyurethanes do not biodegrade, and hence stay viable as an active substrate for 20+ years. Vertical wall systems utilizing polyurethane sheeting typically employ a sandwich construction where a waterproof membrane is applied to the back, the polyurethane sheeting is laid and then a mesh or anchor braces bars secure the assembly to the wall. Pockets are cut into the face of the first urethane sheet into which plants are inserted. Soil is typically removed from the roots of any plants prior to insertion into the urethane mattress substrate. A flaked or chopped noodle version of the same polyurethane material can also be added to existing structural media mixes to boost water retention. Structural media equals. Structural media are growth medium blocks that are not loose, nor mats, but which incorporate the best features of both into a block that can be manufactured into various sizes, shapes and thicknesses. These media have the advantage that they do not break down for 10 to 15 years, can be made to have a higher or lower water holding capacity depending on the plant's selection for the wall, can have their pH and ECs customized to suit the plants, and are easily handled for maintenance and replacement. There is also some discussion involving active living walls. An active living wall actively pulls or forces air through the plant's leaves, roots and growth medium of the wall and then into the building's HVAC system to be recirculated throughout the building. A problem with these systems is that building code still requires all the standard air filtration equipment that would have to be installed anyway, despite the living wall's installation. This means that active living walls do not improve air quality to the point that the installation of other air quality filtration systems can be removed to provide a cost savings. Therefore, the added cost of design, planning and implementation of an active living wall is still in question. With further research and UL standards to support the air quality data from the living wall, building code may one day allow for buildings to have their air filtered by plants. The area of air quality and plants is continuing to be researched. Early studies in this area include NASA studies performed in the 1970s and 1980s by B.C. Wilverton. There was also a study performed at the University of Guelph by Alan Darlington. Other research has shown the effect the plants have on the health of office workers. The effect of indoor foliage plants on health and discomfort symptoms among office workers. Retrieved December 23, 2010. Function. Green walls are found most often in urban environments where the plants reduce overall temperatures of the building. The primary cause of heat buildup in cities is insulation, the absorption of solar radiation by roads and buildings in the city and the storage of this heat in the building material and its subsequent re-radiation. Plant surfaces however, as a result of transpiration, do not rise more than 4-5 degrees Celsius above the ambient and are sometimes cooler. Living walls may also be a means for water reuse. The plants may purify slightly polluted water by absorbing the dissolved nutrients. Bacteria mineralize the organic components to make them available to the plants. A study is underway at the Bitchie School in Seattle, Washington using a GSKY Pro wall system, however, no publicly available data on this is available at this time. Living walls are particularly suitable for cities, as they allow good use of available vertical surface areas. They are also suitable in arid areas, as the circulating water on a vertical wall is less likely to evaporate than in horizontal gardens. The living wall could also function for urban agriculture, urban gardening, or for its beauty as art. It is sometimes built indoors to help alleviate sick building syndrome. See also, Building Integrated Agriculture, Folk Wall, Green Roof, Green Wall, The Hanging Gardens of Babylon, Humulus Lupulus, Musa copyright Edu Kwai Branley, The Green Wall, a film, The Green Wall, the story of a brave prison guard's fight against corruption inside the United States' largest prison system, a book D.J. Vodica about corruption in the California prison system, Vertical Farming. References. External links, Green Infrastructure Resource Guide, Green Wall Tower IPH in Hanoi, Vietnam.